Louis Rosenberg, CEO of Unanimous AI, and we're a very different type of AI company. Instead of replacing people with algorithms, we use AI to connect groups of people together in shared environments, creating unified systems that make people smarter. In other words, we build hive minds. And that's a lot of what I'm going to be talking about today, but because this is an XR conference and because I was involved in some of the very early work in augmented reality, going back 30 years, I'll talk a little first about the Virtual Fixtures project that I did for the US Air Force and how that led me to this unusual place of building hive minds. So my outline for today is it's pretty simple. It's going to start here, Virtual Fixtures project. That's a picture of me in 1992 at Wright-Patterson Air Force Base conducting a test of the Virtual Fixtures system. That was before my hair was going gray and before the phrase augmented reality even existed. And I'm going to talk about that and talk about how that led me here, which is what I'm working on now. That is a technology called Swarm AI. It's a shared environment where hundreds of people from around the world, or thousands, can log in real time and amplify their combined intelligence through a combination of virtual interactions and AI. And that'll take a little bit of explaining to show you how that amplifies intelligence, but it does. But before I get to that, let me take a step back and talk about what connects all these things together, which is people. My view from the early days of my work is that people are amazing. People have intelligence, creativity, dexterity, ingenuity, morality, and my interest has always been to use technology to extend and expand our human capabilities into interesting environments. And back in 1990, when I started working in this area, my interest was focused on amplifying our individual capabilities. How can we amplify the capabilities of an individual person? And that's what led me to VR and AR technologies. And then over the last 30 years, I've gotten more and more interested in extending from individual people to groups of people. And that's what led me to really focusing on how we can use technology to amplify our collective capabilities, and particularly our intellectual capabilities. And that's why for the last 6 years I've been working on hive minds. So let's talk about the Virtual Fixtures project, which began at Stanford University in the Center for Design Research, and it ended up getting funded and built at the US Air Force, US Air Force Laboratories. And so back in 1990, I was a graduate researcher at Stanford, and I had a research job at NASA in their virtual reality lab. And my work focused on stereoscopic displays. And in fact, the impact of interocular distance, the distance between your eyes, on depth perception. And so I was spending countless hours wearing stereoscopic displays and writing code to simulate different interocular distances, and then testing the impact on how people perceive depth perception. And I came away from that experience excited about virtual reality, but actually wanting to take it out of this enclosed space and basically splash virtual reality all over the real world. I wanted to create a mixed reality where the real and the virtual were so seamlessly merged that you could suspend disbelief, that you could consider both the real and the virtual part of the same reality. And just as context, in 1990, virtual reality was new. It had been around for a few years. It really emerged from immersive simulation, and it's kind of a blurry line of where things went from these realistic immersive simulations, flight simulators, to virtual reality. But by certainly by 1987, the phrase virtual reality was around, and there were labs working on it. The phrase augmented reality did not exist yet, and really was not a field of research. At that point in time, there were heads-up displays, like a viewfinder in a camera, or a pilot's visor where you could display information, targeting information. that's a precursor to augmented reality. I would say you're really annotating your view of the world. You're not augmenting your reality. Um, the closest thing in the past that actually enabled the display of kind of a 3D display was maybe the sort of Damocles headset, which projected 3D images in front of you. That goes back to the 1960s. Pretty amazing technology, but it didn't register real objects and virtual objects in this meaningful way. It didn't create a merged reality that would suspend disbelief. And so what I really wanted to do, like my research goal, was let's say, can we create virtual overlays on the real world that are registered to the real world and look and feel and sound like part of reality? And the way I pitched this to the U.S. Air Force, this virtual fixtures concept, was actually thinking about it in terms of surgery, and that was one of the examples that they got excited about. And if you think about a doctor who wants to make an incision with a scalpel, you could do it freehand, or you could use a piece of physical hardware to guide you a straight edge. And if I give you a piece of physical hardware, you could make a much more accurate incision. You could do it faster. It could increase your performance. And so the concept is, well, what if that wasn't a real physical piece of hardware, but it was a virtual fixture that could guide the real scalpel? And so that was the concept, to say, hey, can we create a virtual overlay that could look and feel and sound so real that it could guide your scalpel or other instruments that could allow you to perform tasks with significantly enhanced performance, and because it's virtual, it doesn't have to obey the laws of physics. So you could take this virtual straight edge and you could sink it down into the body. You could prevent your scalpel from going to below a certain depth. It could protect certain vital organs. It could have abstract properties. It could be magnetic. It could be repulsive. And so the idea was, can we create a true augmented reality where real objects and virtual objects are registered in the same environment and look and feel and sound so real that it could enhance human performance? And so to do this, hard parts were spatially registering virtual objects and real objects in the same environment that are so real it would suspend disbelief, and perceptually combine sight, sound, and touch. And so this is not just a visual overlay, but this was including touch that would feel physically real. When your real scalpel hits a virtual object, it should feel like you're hitting a virtual object. It should even sound like you're hitting a virtual object. So the idea was to create this true merger of the real and the virtual that would suspend disbelief, to generate a true augmented reality and amplify human performance. And so the system that started to look like this, which was a person was wearing this full upper body exoskeleton that would allow us to track their hand and arm motions in 3D space. It was a vision system, audio system, and allows to create these virtual fixtures. And for the task, we didn't use surgery. We wanted to use something that was basically general, that was a more generalized task. And so we used this task board, and this was something that had existed for a decade at the Air Force for measuring human performance. And it's actually called a Fitts Law task board. And what you do is you take a peg and you move it from one hole to another hole, and by varying the distance between the holes and the size difference between the peg and the hole, you can create a very carefully controlled set of task difficulties, and you can create this index of performance. And the idea was, well, can we use virtual fixtures? Can we overlay this augmented information into this world and enhance people's performance? And so the system ultimately looked like this. And so a virtual fixture, for example, could be cones. These virtual cones that would appear in space and actually guide your hand as you're trying to put a peg into a hole. And so the studies that were done was a set of different studies, different published results in early 91, 92 was just testing this simple virtual fixtures, rigid surfaces and cones where you could basically guide your hand and into these different holes, and it would feel real. And then there was a set of tests that involved telepresence, looking at time delay. And so the thing about telepresence, and especially for the Air Force, if they want to, say, repair a satellite in orbit and their person's controlling a robot, it's a difficult task, performance is low, and there's time delay. It makes it really, really hard. You move your arm and the robot moves with a slight delay. And even if it's just 250 milliseconds, it's really disconcerting. And so the idea is, well, if we put virtual fixtures into your space, those virtual fixtures would be in your time frame. And the idea was, well, maybe that would enhance your performance even more because it's a degraded environment. And then 93 and 94 was looking at more complex fixtures. Instead of just doing rigid surfaces and cones, started looking at compliant surfaces that feel soft or springy, viscous liquids where you feel like you're moving into a thick cloud of honey, magnetic surfaces that you can stick to or pull off of, even textures that you could feel. So the idea was to start looking at the things you can do that really take advantage of the fact that these are simulated entities. And it worked. And so the first study, we saw 57% of increase in human performance. When we looked at the time delay telepresence study, it was up to 70% increase in performance. And then when we did the more complex fixtures, it was over 100% increase in performance. And so it worked, and it was a successful project. So ultimately, it showed that creating an augmented reality can significantly enhance human performance. But what was most interesting to me, and the thing that maybe impacted me the most, was how excited the human subjects were. I mean, I had to bring in lots and lots of people who would come in and do this task board test and experience these virtual fixtures, and they would come away and they'd say, this is amazing. And not the task board, but this whole idea of virtual reality and augmented reality. And so for me, that was a really big impact. And so in 93, I started a company to go out and start working in virtual reality, a company, Immersion Corporation, which I started in 93. And it's actually one of the few early virtual reality companies that's still around today. I was there till 2000 and left, but really inspired me to do a lot in the virtual reality space. Just seeing at that early time how much people responded to this technology. So I was sure VR and AR would be huge back in 93, and I thought within 5 years it was going to be everywhere, and it's taken a little bit longer than that, maybe 25 years longer than that. Which brings me back to my outline, which is I started out with this idea of virtual fixtures. People are skilled, and can we use this to amplify their skills? And after working in virtual reality and augmented reality for decades, I started to get more and more interested in groups of people, and can we amplify the skills of groups of people? And the skill that became most interesting to me was the fact that people are smart. And can we use shared environments and artificial intelligence to amplify the intelligence of human groups, which leads me to Swarm AI. And so Swarm AI is this unique technology that starts out with networked human groups. They could be anywhere in the world. They have to log into a shared environment. And these are people who have knowledge and wisdom and experience and opinions and insights. And we connect them together in real time with AI algorithms, and we turn them into artificial super experts, experts that can make more accurate forecasts and insights and estimations and assessments and decisions and opinions. And, um, and it's called swarm AI because it's modeled on the biological principle of swarm intelligence, which is evolution's method for amplifying the intelligence of groups. And so what is swarm intelligence? Let me start with an example because it's a good way to convey this. So at Unanimous AI, one of the things that we've done is we've taken on lots of challenges from the media because we say, look, we can connect groups of people together and make them smarter. And so the media says, well, prove it. And so a famous example is we were challenged by CBS Interactive to predict the Kentucky Derby, and not just the winner, but the first 4 horses in order. And in horse racing, that's called the superfecta. And the year they challenged to do it, it was a 540 to 1 odds prediction. And so we started the way we always start, which is with people. And so we found 20 horse racing enthusiasts, not experts, just enthusiasts, and we had them come into our shared environment called Swarm, and we had them work together as a swarm intelligence to predict who would come in first, who would come in second, who would come in third, who would come in fourth, and I will show you how that works. And this means we have these real people, they're connected by AI algorithms, they functioning as this super expert to make these predictions. We refer to this as artificial swarm intelligence or swarm AI. And so this swarm AI generated these insights, these optimized insights. We gave them to the reporter, said, hey, here's what we think will happen, first, second, third, fourth. And she wrote a story about it and published the predictions, which put some pressure on us. And then she actually went to the Kentucky Derby and placed a bet on the superfecta and tweeted it out, which put even more pressure on us. And the reason that this is a famous story is that it was perfect. Anybody who had placed a $20 bet on those 4 horses would have won $11,000. I placed a bet and won $11,000. The reporter placed a bet. A bunch of her readers placed bets, and that's, amazing. In fact, one of her readers reported winning $50,000. But what's actually more interesting is if you go back and you look at those 20 people who, as individuals, not a single one of them got all 4 horses correct. And in fact, had they just taken a vote, they would have gotten 1 horse right out of the 4. But when they worked together in the shared environment as a swarm intelligence, they were perfect. That's the power of swarm AI. So how does it work? I like to say it all goes back to the birds and the bees and fish and ants, because all these creatures have evolved methods of amplifying their intelligence by thinking together in systems. This is why birds flock and fish school and bees swarm. They are smarter together than alone. Now, I'm not talking about crowdsourcing like we humans do by taking votes and polls and surveys. I'm talking about forming real systems with feedback loops that are so interactive that a new intelligence forms, an emergent intelligence that's smarter than any of the individual members. I'm talking about forming a hive mind. And biologists refer to this as swarm intelligence, and it exists in nature, and it allows groups of organisms to significantly amplify their intelligence. I like to think about it this way. A brain is a system of neurons that's so deeply connected that a new intelligence forms, while a swarm is a system of brains that's so deeply connected that a superintelligence forms. Said another way, a swarm is a brain of brains, and it can be smarter than any individual member. So swarm intelligence, so nature evolved this method of amplifying the intelligence of groups. And again, if you think about nature, if there's a school of fish, they're swimming around the ocean as a single organism, a superorganism. They each have slightly different views of the world. They have slightly different experiences. They have slightly different a sense of what's going on, and they have to make decisions together as a group. And so how do they make those decisions as a group? What nature does not do is nature does not take polls or conduct surveys or run focus groups. Nature also doesn't analyze big historical data sets. There's no big data in nature. What nature does is it forms systems, real-time systems where the groups can think together and converge on optimal solutions in unison. And they become smarter together than alone. So how smart are swarms? So let me give a biological example just because it's amazing. And so this is a honeybee swarm. It's actually about 10,000 bees. And and they have a life or death decision that they need to solve. They need to find a new home to move into. And that new home could be a hole in the hollow log, or the hole in the side of a building, or if you're unlucky like I was, the crawl space in your garage. And this might sound like a simple decision, to find a new home, but this is life or death. A bad decision could impact the survival of the colony for generations. So how do they do it? It's amazing. They send out hundreds of scout bees that go out into the world and search 30 square miles of area, looking for different sites. Then they bring that information back to the colony. And that's data collection. That's actually the easy part. The hard part is they now need to decide which of all these different options, and they'll find dozens of different options, should they move into. And it turns out that honeybees are very discriminating house hunters. They have a lot of constraints they need to satisfy. It becomes a complex multivariable problem because they need to find a home that's large enough to store the honey they need for the winter, that's ventilated enough to stay cool in the summer, that's insulated well enough to stay warm in the winter. It has to have an entrance that's small enough to block predators, but large enough to allow lots of bee traffic in and out. It has to be waterproof, so it's protected from the rain, and it needs to be near water for bees to drink. And of course, it needs to be well located near a source of pollen. To pick the best possible site across lots of different options with all these competing constraints is a multivariable optimization problem. A single bee cannot possibly comprehend this problem. A single bee has less than 1 million neurons in its brain. Its brain is smaller than a grain of sand. You have 85 billion neurons in your brain. So however smart you think you are, divide that by 85,000, and that's a honeybee. So you probably wouldn't want a honeybee picking a new home for you. And yet, it's also worth saying that if you were a human CEO, you might be faced with a similar problem. You're trying to find the perfect location of a new factory, or the perfect location of a new store, and you're trying to weigh all the different competing constraints of, is it near workers, is it near roads, traffic, etc. And it would be very difficult to optimize that. Honeybees have this complex problem, and they solve it. Swarm intelligence allows bees to converge on the optimal solution with over 80% success. And biologists have done amazing experiments to discover that. But that's the power of swarm intelligence. So how do they do it? They do it by forming an intelligent system. And that intelligent system takes in noisy data about the world, all the data about the different houses, the different home sites that they've discovered, all the different criteria. They process that data in real time, and then they generate an optimized solution. Now, I know what you're thinking. These are honeybees. How do they process data in real time? They actually do it. They do it by vibrating their bodies. To us humans, it looks like the bees are dancing. And so biologists call this a waggle dance. But really, they're generating signals that represent their support for the different home site options that have been presented. And so they are vibrating their bodies, representing their support, and they're doing this as a system all together in the same environment. And it basically becomes this multi-directional tug of war with bees pulling and pushing in different directions until they finally converge on the one direction that they could all agree upon, and it's almost always the optimal solution. And so that leads to this question of, well, can people form a swarm intelligence? We did not, if birds and bees and fish can get smarter together, can people do it? We did not evolve the ability to waggle dance or to swim around in schools, but we've created amazing technology. We've put computers on everybody's desk and phones in everybody's hands, and we've enabled people to come together in shared environments from anywhere in the world. And so the answer to this question ultimately becomes yes, if you use the right technology. And so this is a natural swarm, and my team at Unanimous AI, we've been studying natural swarms for the last 6 years and developing the algorithms and interfaces that allow humans to form similar swarms in shared environments online. And so this is an artificial swarm. Each of those little magnets that you see is controlled by a person. They can be logged in from anywhere around the world. Those magnets are pulling on the swarm. And so by adjusting their magnets with a mouse or a touch screen or or their phone, they're adjusting the position and orientation in real time, and they're all basically pushing and pulling in much the same way that a group of bees waggle dances. And we can use this to ask and answer questions and to amplify intelligence. And I should mention that there are basically AI algorithms that are watching all the behaviors in real time and determining the direction that the swarm should move. And so a swarm as a real-time system with the participants logged in from anywhere in the world, acting and reacting and interacting to reveal the strength of their convictions to the underlying algorithms. And here's a group of people actually doing a financial forecast. And so they are all pushing and pulling, and they're answering a question that appeared on everybody's screen at once, and I'll show that. But it gives you an idea of how this can allow groups to actually converge on solutions to problems. And so over the last 5 years, we've been working with universities around the world to test this idea of artificial swarm intelligence and asking and answering questions. And I'm going to talk about a few of the studies that have been published recently. We did a study with researchers at MIT. We published this last year showing, and this was showing that financial traders, and the idea was this: you had financial traders were asked to predict the price of oil, the price of gold, and the S&P 500, predict the weekly change every week over 20 consecutive weeks. And they were asked to do that alone as individuals. They were asked to do that basically by taking a vote, and they were asked to do that as a swarm intelligence, converging on solutions. And the published study shows that when they work together as this hive mind, we could amplify their accuracy by 26%. We did a study with Stanford Medical School, published in Nature Digital Medicine last year, where we looked at enabling groups of doctors connected from different medical schools to diagnose chest x-rays together as a swarm intelligence. And these were relatively small groups, 5, 6 doctors. Chest x-ray would pop up on all their screens, and it would ask them to diagnose, does this person have pneumonia or not? And what we found was that when they worked together as a swarm, we reduced their diagnostic errors by 33%, which shocked us, because these are experts. These are doctors who went to school for 12 years to become a radiologist, people at the top of their field. But even these experts, when they come together as a swarm, we could amplify their intelligence significantly. We did a study with Oxford University looking at predicting sporting events. As we took groups of sports fans, not experts, just regular sports fans, and we asked them to predict the outcome of 50 consecutive soccer games over 5 weeks in the English Premier League. And they would, what we found was that as individuals, they were 55% accurate in predicting each of these games, win, lose, or draw. But when they worked together as a swarm intelligence, they were 72% accurate. So huge increase in accuracy, and these were not experts. These were enthusiasts amplifying their intelligence. And then we did a study with California Polytechnic looking at business teams, 60 business teams. Each one had about six people in the team, and they were asked to take a subjective judgment test as a business team. And what we found was that on this subjective judgment test, that when they worked together as a swarm, we reduced their errors by 52%. And even comparing it to if they had just taken a vote as a team, we reduced their errors by 41%. So this technology works across different domains, from sports fans to business teams, and really very, very exciting. So how do people swarm? How does this actually work? So I'll give you another example, another challenge from a reporter, Newsweek, over a few different years, challenged us to predict the Oscars. And so let me show you how this tangibly works. First thing we do is we find, in this case, movie fans. We found 50 movie fans around the US. We invited them into our software platform called Swarm, which is a real-time environment. People can log in from anywhere. All they need is a standard browser. Each participant gets an invite. It could be by email, text, calendar, Slack message. They click on the invite and they come into Swarm. And then they enter this Swarm workspace, which is, I would consider it as basically two-dimensional shared virtual environment with real interactive physics between the people, and you'll see that in a second. This is what the Swarm interface looks like. There's an area where the group can chat, and usually there's a moderator who's asking the questions. In this case, they're going to ask questions about who's going to win Best Picture, who's going to win Best Actress, etc. But that the moderator in chat can just communicate with the group. There's an area to share media, pictures, video, so all the participants can answer questions about the same things that are shared. There's a place where we can see who's in this environment. Here, there's 9 people. But there could be 900 people. And then the interesting part is the Swarm area. And usually people just zoom in on the Swarm area. And so what happens is this is on everybody's screen. A question is going to appear on everybody's screen at the exact same time. A set of options are going to appear on everybody's screen at the same time. Each person's given the ability to control a magnet with their mouse or touch screen or trackball or phone. And then they move their mouse next to this glass puck. And then the Swarm starts. And so everybody interacts. And here's 50 people acting and interacting, everybody pushing and pulling, they're adjusting their angle and distance of their magnets as they're basically negotiating. And AI algorithms are watching their behaviors and determining from their behaviors different levels of conviction and determining how the Swarm should move. And there they predicted the answer. We did this for all the different questions. And what's important to kind of realize is that this interface is designed to really look simple. It doesn't take any real instruction. People just say, come into the environment, this is how you control a magnet, this is how you interact, and people can do it. But although the interface looks simple, the important thing is to get these people to behave in real time, to act and interact and have AI algorithms watching their behaviors in real time. So what the AI engine is seeing is this. It's seeing this cloud of behaviors, and it's been trained to understand that what each individual behavior looks like. Is somebody have high confidence? Is somebody have high conviction? Are they ambivalent? Do they have high conviction in certain options but willing to concede in others? And so it's watching everybody in real time, and so it becomes this feedback loop. That's really, really interesting. So that basically at time 0, question appears, everybody acts, the AI algorithm watch how they act, determine how the Swarm should move, but then the Swarm moves. And as soon as the Swarm moves, everybody reacts. And so what you have here is that the people are influencing the AI is influencing the people, and the system's converging together on solutions. And so how did we do on this Oscar prediction? Well, we were 94% accurate, which was better than the human experts at some of the top places, at Variety, at LA Times, Vanity Fair. We also compared to Gold Derby, which is a crowdsourcing site where hundreds of thousands of people just fill out a survey and they aggregate. So this small swarm of 50 people can outperform a big crowdsourcing site. We also compared to Bovada, which is a Vegas betting market where large groups of people place bets. And then we did better than the Rolling Stone magazine. So what are the business applications? You can probably imagine lots of real-world applications for this type of technology where you can take a network creaming group, have them come together as an artificial expert. We like to break it up into really 2 different categories. Internal teams, internal business teams. Every organization has a marketing team, sales teams, engineering teams, and those teams can amplify their intelligence as artificial experts. And external groups, groups of customers, groups of retailers, groups of restaurant managers. If you're a big restaurant chain, we can amplify their intelligence as artificial experts. And so for these internal teams, we've worked with lots of Fortune 500 companies that are amplifying the intelligence of their sales teams to make sales forecasts, amplifying the intelligence of their marketing teams to optimize marketing messages, engineering teams to forecast how long a project is going to take or how much a project is going to cost, financial team, hedge funds. We currently work with a number of hedge funds to make financial forecasts where they bring their analysts together as a swarm intelligence. For external groups, We do lots of work with companies doing market research where they bring in groups of their customers and amplify their intelligence to make predictions about product features or whether products will sell or whether advertising messages will resonate. We do political forecasting, sports handicapping, expert panels. We've worked with groups where they have groups of experts spread around the world and they need to come together. In fact, one of our customers is the United Nations, and they have experts around the world that predict, that try to predict food insecurity for different nations. And they've been using Swarm to have their experts come together and make more accurate predictions about the food insecurity of different countries. And so lots and lots of different possibilities and capabilities you could imagine. These are some of the companies that have been using Swarm Intelligence. Lots of really interesting applications from medical, from forecasting the outcome of medical trials to forecasting sales. Frito-Lay is a customer. They have marketing and sales folks all around the country, all around the world, and they've brought people together as a swarm to predict what will happen if they make a price change to a particular product. How will that sell? The Miami Heat, the basketball team, that's actually an interesting example where they wanted to predict what features their season ticket holders would respond the best to for if they're trying to sell season tickets, like what are the benefits? And so they would bring in groups of their season ticket holders into swarms and make optimized forecasts about which types of features would resonate the best. The X Prize used Swarm to they bring their experts together. They call them visioneers and predict what kind of future X Prizes would have the most impact. And so really wide range of potential applications. And again, it goes to any application where you have groups of people and you want to amplify their intelligence as a unified artificial expert. People often ask, how do you compare Swarm AI to traditional AI? Because both have their place and both really can do amazing things. In traditional AI, you start with big data, huge data sets where you can do machine learning on it and generate actionable insights, and it works in many, many places. But the one thing that people don't talk about is that for real-world business applications, there's lots of applications where the big data doesn't exist. It either just doesn't exist in a database you can access, or it does exist, but it gets out of date really, really quickly, and you really can't use it for forecasts or insights. Swarm AI kind of opens up another database, which is the human database, the human knowledge and wisdom and insight and intuition, human experience. And the thing about people is that we are data collection machines. We're out there in the world constantly collecting information about our world, keeping ourselves up to date on so many things, from the political climate to the economic climate to product climate, what products are hot. And so there's all this information, this human database, and what Swarm AI does is it basically uses Swarm intelligence to generate actionable insights. And so again, Swarm AI really brings the power of AI to the human database, and it does use traditional machine learning as part of it. It just doesn't start from a big data. It starts from human data. And so, in summary, people are smart, and I would go even further to say people are amazing when you're thinking about what we can, why we do virtual reality and augmented reality. But in terms of bringing people together into a shared environment for swarm intelligence, we start with this idea that people are smart, they have knowledge and wisdom and insight and experience, and we can harness that and not replace people with AI, but actually connect people with AI to make them smarter together. Thanks.
Oh, this is not a presentation. This is, I don't know, kind of opera music. Yeah. And one very specific question everyone should ask you, is not normal. Are you rich since you discovered this?
For making predictions and um, yeah, I mean, we definitely do use the technology for making predictions and forecasts, and it's one of these things where it's certainly, people always ask, well, why don't we just bet on sporting events all the time?
Yeah.
But I mean, for me, it's most interesting and most exciting to just to work with new different groups. To work with new different groups that that can amplify their intelligence in different places, and look for uses that go beyond just forecasting, but also because one of the things that we found is that, you know, you can bring groups of people together in an environment, you can connect them together, and you can amplify their intelligence for things like forecasting. But we also find that we can amplify their wisdom as well. We can take groups of people together and allow them to make not just smarter predictions, but wiser decisions. And so we've been working with political groups and social groups, and because that ultimately I think is where the biggest impact would be, which is really to help groups of people make better decisions, because that's really where people fail. we as a species have made a lot of bad decisions, and I think part of it is that we don't have we evolved to make good decisions in small tribes. A small tribe of 10, 20, 30 people can make a good decision. Now that our world has, requires input from millions or billions of people, we don't have the tools to do that. And the tools that we do have are things like votes and polls and surveys. And my view is that that those are actually damaging to people. And nature shows us that's a different way to make decisions. And if you look at, like, let's say polling, which and so much of our world is driven by polling right now. Polls are polarizing. That's what a poll does. A poll doesn't help.
It enriches the pollers.
It doesn't help a group reach a decision. What a poll does is it actually shows where everybody disagrees. A poll will highlight the disagreements in a population and do nothing to bring them together. But nature doesn't take polls. Nature builds systems, builds swarms, because it instead highlights where groups can agree, and it points a group towards decisions that are actually best for the whole population.
But you mean we mustn't use at all some polls, or it could be it can't be in your vision polls. I mean, I need to understand how you conduct the interviews, etc. But the way we are doing polls actually is totally inefficient.
So if you look at a group of people as a source of knowledge and wisdom and insight, and you say, okay, I've got this group of people, they all have something valuable to share, and we have this important problem to solve. How do we solve that problem? If I take a vote or a poll or a survey, I'm not really harnessing their combined intelligence in an efficient way. And in a lot of ways, when you collect people's opinion through, say, a survey, they actually feel like, oh, I'm just throwing my opinion into a black box, and if the end result doesn't come out to agree with what I thought, then nobody cared. And again, if we look to nature to say, well, nature's been addressing this same issue for hundreds of millions of years, where organisms like a school of fish that's navigating the ocean, and it's navigating the ocean as a superorganism. All these different fish have slightly different experiences, different perspectives on the world. They're seeing things from different angles, and the way they combine, the way that nature combines all of these different perspectives in the most efficient way possible is as this real-time system. and that's bringing this back to to extended reality. What we're building when we enable virtual environments is a place where groups of people, tens, hundreds, thousands, millions, can come together in real time. And my interest is saying, okay, how do we use that infrastructure to harness their intelligence, to make smarter predictions and forecasts, but how do we also use it to harness their views and opinions and morality to make wiser decisions about the future?
Is there any question from the public? Please let me check the chat, maybe. Do you think that there is kind of limit? When do the group of human becomes inefficient in being a swarm? When a swarm began to be too big or something like that? You have this?
Yeah, no, it's a good question. And it's actually one that that when we started working on this, we really had no idea, would it be, should there be swarms of 10 people or 10 million people? And we can actually also look to nature. So the species that have been studied the most for swarm intelligence is honeybees, and it's been studied for 50, 60, 70 years. And a colony of honeybees has about 10,000 bees, and they, as I talked about, they have to make these life or death decisions. What they do, they tend to use 300, 400 bees out of the 10,000 to make a decision. They don't use all 10,000. And we've found something similar, which is when we bring groups of people together, size of 100, 200, we see a continuous amplification of intelligence when we go 10, 50, 100, 200. But at a certain point, we see diminishing return. We could, you don't get much benefit if we add, go from 200 to 2,000.
Is there any link with the Pareto laws, like 80 and 20%? It's saying that there is 20% of the people who are efficient in a group of 100. The Pareto. Oh, I don't know how to.
Right. So
is it a kind of a law, mathematical law?
So it's not clear that it's a mathematical law because it depends on the type of people. So if we're going to pull together a group of people from the general public, then there will be a percentage of the people who maybe just don't know enough about the topic at hand to contribute. If we bring together a group of experts, then they all they're all very valuable. And so that's one of the things that's interesting is that if we're going to bring a group of people together who are let's say to predict an election, we can bring together 100 random voters, and they can predict an election very, very accurately, more than if you did a survey of 10,000 people. But if we're doing something like diagnosing a chest X-ray, like we did with Stanford, we can bring together a swarm of just 5 doctors because they're experts and they know what they know what they don't know. They're better calibrated in how much conviction that they should have in their opinions. And so, the optimal size really depends also on the level of expertise of the group.
I understand, but what about internet? The swarm of the machine. You can I mean, this is a network. Everything connected. So. Can we, in your concept or your theory, think about internet like a swarm, the swarm of swarm, and then try to get something using your models actually? It makes sense? Or it should be absolutely human?
So some great a great question,
Thank you.
and
It's important.
because it definitely we definitely see a benefit of having a swarm of people, but also bringing into that artificial intelligence. And in fact, the study we did with Stanford Medical School, there was actually two parts to the study. The first was to have groups of doctors perform, diagnose chest X-rays, and then we did the second study where we then compared that to deep learning. And at Stanford, they have a system called ChexNet that is like one of the best deep learning systems for diagnosing chest X-rays. And what we found was that we could elevate the human doctors to perform better than the AI, but the AI was still good. And when we studied it, we found that the AI and the humans were good at different things. They were good on different types of cases. And so the AI was really good at cases that were common, where, because the AI is trained on this huge data set of, hundreds of thousands of different X-rays. And so for common cases, the AI was better than the humans, but the humans were better at the rare cases, the things that no one had ever seen before, because like they have, wisdom, and their wisdom is basically the ability to
intuition too.
Right. They have intuition, they have wisdom, and that's their. And so what we did was we then built a system that said, what if we use the two together, where we combined the benefits of the deep learning and the benefits of amplified human wisdom, and we achieved an accuracy of diagnosis that was better than either by itself. It was the highest level of accuracy. And so it definitely does point to this idea that, yes, there are things that machines are good at, but there are also things that humans are good at. And my interest is keeping the human part in the loop, because there's so much AI research out there where people are just throwing the humans away and just saying, oh, it's more efficient to just, process big data. But the big data, is losing a lot of these things. And for something like, diagnosing a chest X-ray, human wisdom is important. But for something like solving a problem about, a political problem or a climate problem, it's human. It's not just wisdom, but it's human morals and human values and human sensibilities. And so it's a way to make sure we keep, these very important human aspects part of decision making. At least that's the thing that motivates me in this project.
Really, really. I'm like a fanboy. I hate to say that, but I like it. What you're doing, it's amazing, really. And
it's certainly the type of thing that that your group could use. Like, so let's say you have experts in extended reality that are all over the world, and let's say you wanted to forecast what's the future of extended reality look like. Having those people come together in a swarm is a way to harness their unique perspectives, and it actually, what we found is that swarms work the best when the group is diverse. So people who have different backgrounds, different expertise from different locations, they can come together and they can generate insights, really good insights about what is the future of this technology space. And like I said, we've done that with other groups. We do that with we've done it with the X Prize when they're bringing together their groups. And I mentioned we're currently doing that with the United Nations, where they're looking at a very different issue, where they're looking at trying to assess food insecurity of different nations around the world, and they have experts on every continent, and they want to harness the different perspectives of all these different experts, and they can come together in a swarm, and they can give really, really deep insights quickly. So it is a way to to capture the unique perspectives and the unique experiences of large groups that could be anywhere, because they're all coming together into this, shared environment. You're muted. Yep. You should you're muted. Can you hear me?
Your mic.
I say just was my very last question. I know we did too much on your time for the interview, etc. My last question is, okay, now you come up to the swarm. So you're trying to bridge the human and the machine, the two folks, and then bring them. But so swarm, the group, without the group, the individual doesn't exist. But do you think that anyway in this model there is something missing? Is the kind of lonely cowboy, the hero, someone who come and disrupt like you did 30 years ago with the virtual fixture, or Tom Furness, or whatever, Einstein, me, sorry. No, bad example. So when do you will use this singularity in your swarm? Makes sense, my question?
Yes, I mean, so there's definitely this question of the individual versus the swarm, the group, and the objective is not to replace the individual. Individuals have, they're going to have their own inspirations, their own insights, and that should always exist. The question is, okay, when you have individuals who are out there working on their own, developing their own insights, developing their own perspectives, because that's what we want. We need that. It's like the scout bees in the example that I gave. That the honeybees, they make good decisions as a swarm because the bees are out there in the world on their own, getting their own perspectives and insights. It has to work together, and so it's really about this one part of the process where, okay, you need to, a group needs to make a decision, or needs to, how do you harness all the unique insights of the individuals in an effective way? And right now, the ways that people do it, especially, there's political ways where people take a vote, or in businesses people take a survey, or they go to a business meeting and it's very political, and there's what we find is that when people come into a swarm of say 100 people, and then we interview them after and we say, well, do you feel like you were consequential? They all say yes. They'll say they feel consequential because they it's not like just dropping a survey into a box. They feel like they were part of the decision. And so even if the decision is something that they didn't agree with, they experienced how the group reached that decision. So they have more buy-in to that decision at the end because they were part of this organic process, and they in some sense come away understanding the group better than they did before, which the short answer is the individuals are still the most important thing, and the individuals out there having those unique inspirations is really what makes the swarm work, because the swarm is when those individuals come together to reach a decision.
Your mic again, Jean-Philippe.
I say, congratulations, you just discovered communism. Sorry, I know it's a bad word in the US, sorry. Okay.
I think we should give the
time.
To,
I asked to the attendees for a question.
Yeah, Emmanuel wants to ask a question. Can you allow him, please, to speak?
Yeah, you should.
I'm not the host.
Yeah, you can speak. You
Is it
can speak,
okay?
Emmanuel.
Yeah, I will start the video. It's more if I can. I don't know. Yeah.
We have another speaker also. Yeah, Mohamed
Okay.
is waiting.
Thank you for the presentation. I'm Emmanuel. I'm working on. I'm interested in knowledge elicitation, and I'm working on expert system modeling through Bayesian networks, so probabilities of elicitation and so on. And my question was, in the panel choice, do you have a kind of calibration of weight according to the people that answers, because a boss doesn't have the same powers and etc.
Right.
And do you have a sensitivity analysis of the results before?
Right.
After? Yeah.
Right. So great question, and that really gets at the heart of how these swarms work. The first thing is everybody's anonymous and everybody's equal, and so a boss and their team are equal, and they don't even know who the boss is. That said, the AI algorithms are watching everybody's behaviors and adjusting the strength of each person's impact based on their behaviors, not based on their status, not based on their hierarchy, but based on their behaviors. And so the AI is able to determine which person has high conviction or high confidence in their opinions, which person is ambivalent, based on how they're behaving in the swarm. And so it is scaling the impact that different people have, but based on their behavior in a particular question, not based on any predetermined status that they might have, because for the most part, people are pretty well calibrated.
Tu commences tout de suite, t'inquiète.
So, yeah.
And the power of the action is determined by what medium? It is the speed of click.
So when in the little magnets that you're controlling, you're controlling them. It's not a vote. You're controlling them in real time. So you're moving the magnet next to the puck, and so as the puck is moving, you're either chasing the magnet or moving out of the way of the magnet. And so it's looking at how you're controlling it. It's looking at what you're doing every 250 milliseconds, and so it's seeing, some people will be resisting the swarm, and at some point they concede to the group. Other people never concede to the group. Some people concede right. So it's looking at how they're behaving, as well as if they're switching, when they're switching, and it's determining what that means for them in terms of their conviction. And because there's lots of different options, they might have high conviction with respect to one or two options, but ambivalence with respect to others. And so it's looking at these complex behaviors in real time.